afternoon. Again, thank you for sticking around after lunch. My presentation is titled The Role of Smoke Control Systems in NFPA Codes. I wanted to touch on this topic because I believe there's some confusion when it comes to NFPA and the role of smoke control that it plays in developing fire safety strategies for buildings. One question I always get is when and where smoke control systems are required. And I wanted to go through and how we determine where these smoke control systems are required in our buildings that we're going up in the UAE and Abu Dhabi and Dubai and even these super tall buildings going up around the world. And one distinction I always get is, well, where is it required? Where can I find the requirements for smoke control systems? And what I've seen is a tremendous step in the right direction here in the UAE with the adoption of formalized fire codes. The next step is to get to the next layer of clarity and informing building designers on how to find these requirements. So I'm going to tie this back into NFPA because that's what I know and that's what I'm familiar with, and compare it to what we see throughout the region. So when we're trying to find out what the requirements are for smoke control systems, is we find out what documents are going to tell us what's required, and that's when we come into a whole list of NFPA codes and standards. And to clarify, the codes are the overarching documents that tell us when and where systems are required, as opposed to the standards, such as NFPA 13 for sprinkler systems, which tell us how to design and install such systems. So as an example, NFPA has a number of different codes and standards, but two of the primary codes would be NFPA 5000 and NFPA 101. Now, when I first moved out here 5 years ago and started working here 8 years ago on certain projects, everything tied back to NFPA 101. That was the standard of life safety in our buildings. But quickly you identify, if you go through the requirements of NFPA 101, is that it's not a building code. It doesn't tell you what materials to use. It doesn't tell you how to produce firefighting strategies, so on and so forth. That's where NFPA 5000 comes in handy and identifies all those requirements as well as the life safety provisions. So in these codes, it gives us a scope. What is this code really intended to do? And I wanted to highlight the difference of the scope of a building code as opposed to the scope of a design standard, so you can see that these are the overarching requirements. So here, this is the scope of NFPA 5000. And whenever I'm not familiar with a code or a code that I haven't used in a while or a standard I haven't used in a while, I always look at this upfront section to see, is this the right one to be used? Well, if we're going to start developing a building strategy, you first start with Chapter 1 of NFPA 5000, which will tell you when it applies to your building. And what you'll see in the purpose here is that this code provides minimum design regulation to safeguard life, health, property, and public welfare. And where does it apply? Well, it applies to all buildings and structures within the jurisdiction. So that's pretty clear that if we're designing a building, this code does apply. Now I wanted to compare that to a typical NFPA standard. Since we're talking about smoke control, I've highlighted the two primary smoke control standards, which is NFPA 92, standard for smoke control systems, and NFPA 204, standard for smoke and heat venting. So here, if you identify in the scope of this document, you'll see that it says the requirements specifying the conditions under which smoke control systems shall be provided are addressed by other codes and standards. So we'll typically be in a debate with an individual and saying, well, what's required and what's not? And they'll say, well, NFPA 92 requires a smoke control system. Or really it's the other way around, whereas NFPA 101 or 5000 would require the system, NFPA 92 would just tell you how to design and install it. So if we go to NFPA 101 and 5000, well, what systems then are required under a typical NFPA fire strategy? Well, you'll start with your smoke-proof enclosures. Those are probably the most predominant smoke control systems that you'd find in NFPA. Smoke-proof enclosures are for your exit stairs, typically in high-rise buildings, or unique occupancies such as air traffic control towers, where you might only have a single stair, or where you have underground buildings where we want to prevent smoke from following people up a stairwell. We want to prevent smoke from getting in there, so you can either do the smoke-proof enclosure or an equivalent venting arrangement at grade. The second type of smoke control system you'll commonly see in NFPA 5000 and 101 are smoke management systems. These systems are really intended to maintain tenable conditions at certain areas of the building so that people can escape. So you find this in areas where you have legitimate stages. So this here wouldn't be a legitimate stage. This is just a platform. Whereas if this was a performing arts theater, where you have larger combustible fuel loads and you have people in the audience, that's when you would require venting of the stage if there's scenery that had ignited, or you require exhaust in that area. An alternative to that would be smoke-protected assembly seating. If you can't just protect the stage, you protect all the audience as well. And what you're doing is you're exhausting the smoke that's being produced by the fire at a rate that it stays above head level, in which case you are deliberately maintaining tenable conditions for a certain duration. And the last area is for atrium spaces in malls where you have large floor openings where you want to protect people that aren't actually directly involved with the fire. So you might have a fire in a retail shop, but the people that are being exposed to the fire or to the smoke are the people that might be on an upper floor that have more volumes of smoke reaching that upper layer and accumulating in that upper layer, where you want to allow those people to escape because they might not readily know that that fire is going to be affecting them. And the last kind of smoke control system that you'll find in NFPA is a smoke containment system. And this is not really intending on maintaining tenable conditions, but what it's intending to do is to prevent smoke from spreading to adjacent areas by overcoming the pressure of the heat of the fire. In which case, under NFPA, this is really only required in underground buildings, where you don't have other means to let smoke escape the building, such as through exterior windows or breaking windows due to flashover. So, not to be confused, there are other mechanical systems that we use to ventilate our spaces, but these are more just ventilation systems, not falling under the regime of smoke control. So you'd have hazardous and special use ventilation. So for example, our generator rooms and our pump rooms need to have ventilation rates. Enclosed parking structures, again, it does serve as ventilating smoke from the space, but it's really just a ventilation system falling under other NFPA standards, NFPA 88A or NFPA 90A. And then we have our kitchen hood exhaust systems, which would again fall under the kitchen standard, not to be confused. So the confusion arises is when we're developing these fire strategies and we start adding various complexities in our smoke control strategy. And a number of systems that we see that aren't required by NFPA would be corridor exhaust, corridor pressurization, hoistway pressurization systems, firefighting lobby pressurization, warehouse smoke and heat venting, just plain mercantile occupancies that don't have floor openings are not required to include a smoke control system. And just because a room has a lot of people in it doesn't necessarily mean you need a smoke control system. Well, why not? Well, wouldn't it be better to have all these smoke control systems? Well, that's what I'm here to present really today is, well, why not? And why does NFPA not include all these other detailed systems and other detailed requirements? Well, in summary, because NFPA has identified that there are better alternatives that we already use in our building. But to understand the intent of these other alternatives is they also play a role in our smoke control strategy. Additionally, smoke control systems that are active have a lot of assumptions, primarily regarding leakage rates. So even in the design phase, we need to assume whether a wall will have leakage through it or not. And then through design phase, we need to make sure it's specified correctly, and then built correctly, tested correctly, and then beyond that, there are changes to buildings. And no one's going back and redesigning the systems when you might have a electrical conduit that you want to put through the wall. But now the subcontractor is not a fire stopping contractor, so he just puts his conduit through a wall, and now you have additional openings, which aren't taken into consideration. In addition to that is the difficulty of commissioning and testing smoke control systems. NFPA identifies a few different types of systems in your buildings and features in your buildings that need to have special commissioning and testing done. It's going to be your structure, spray-applied fireproofing material, and smoke control systems. The reason being is because smoke control systems are so complex and involve so many different people that there's a lot of areas that can go wrong. For you to commission a smoke control system, you typically need your fire protection engineer, your air balancer, you're going to need your general contractor, your fire alarm subcontractor, mechanical subcontractor, door hardware contractor, and you typically need an agency to manage the whole process so that people aren't opening, closing doors, that the rooms have been integrity tested, so on and so forth. So with these complexities, I want to share with you some of the better alternatives that are already identified in NFPA and to bring to awareness the differences between some of these alternatives and when they're typically used. So the biggest and best alternative that we found through research and previous fire statistics in the United States is sprinklers. Sprinklers provide the best form of smoke control in your building. If your sprinkler system works, it does a number of different things. And it's already required in most of our buildings. You can see here, all high-rise buildings now need to be sprinkler protected. Assembly areas that have large occupancies, more than 300 occupants. Educational occupancies that are basically larger than a villa. All healthcare, all new healthcare in the United States needs to be sprinkler protected. All hotels need to be sprinkler protected, so on and so forth. And the benefits of our sprinkler systems are typically they're monitored. So we have our flow switch that tells us if there's actually a fire in the building. So they can provide occupant notification to get people out quickly. Also, they provide suppression. And smoke development is basically just directly related to our mass consumption. However much fuel is burning, that's how much smoke is going to be released depending on the material. So we can limit the mass consumption, limit the smoke yield, and limit the heat, which by limiting the heat, we can limit the pressure that's created in the room to limit the amount of smoke that's being forced out of a room. So I have a very simple example. This is a healthcare facility that we had worked on here in Abu Dhabi. And I'm just going to show you the layers that we've added to our smoke control strategy that would typically be required in NFPA. So the first layer is we're going to add our sprinkler protection throughout our facility. And now all light hazard occupancies require quick response sprinklers. So these quick response sprinklers are going to activate within minutes. The next item is we have our compartmentation. And our compartmentation has a lot of layers to it, which we still don't fully touch base on here in the region. And the first and probably most prevalent is our horizontal assemblies. They're basically our floor slabs. So in NFPA, by default, every floor is its own fire and smoke zone. All right? So these are required wherever you have fire-rated construction. So any high-rise building, any parking structure, any mall building. And actually, if you go to the UAE Fire Code, all your buildings are required to at least have a 1-hour fire rating. So basically, all floor assemblies in the UAE should be meeting these requirements for horizontal assemblies. So some of the exceptions to these are already addressing the smoke control strategies of your building. So where you don't have a horizontal assembly, you need to meet one of these other requirements. So a convenience opening, for example, would be in a hotel lobby. But one of the requirements for a convenience opening, or for a convenience opening would be like a office building that has a tenant occupying 2 floors, right? They want the convenience of being able to go between 2 different offices without the robustness of a fire-rated enclosure. But we address these by making sure that any of these 2-story openings are not connected to our means of egress system. So as soon as you get out of that space, you're protected from the smoke spreading between those 2 floors. Communicating space would be like hotel lobbies, where you have larger floor openings, but one of the provisions of communicating spaces is that everybody in the communicating space must instantly know when there's a fire. So they must be intimate with that space. If they're not in that space, their exits need to be independent of that space. Meaning, if they're not immediately aware of a fire, that's okay, because they have other routes to get out of the building. And then there's the atrium spaces, which we talked about, similar for malls, and if you have, like, for example, Burj Al Arab, where you have a very large floor opening in your building, that's when now you're required to have a very detailed smoke control system, because there's no other better alternatives. You have high ceilings, so sprinklers don't typically work, so you need to maintain tenable conditions for people to escape from those spaces. And then you have service openings and mezzanine spaces, which are more just for practical uses in, let's say, warehouses that want, mezzanine for storage or for offices and so on and so forth. So this type of containment is required to be continuous, so you don't form these gaps in your protection. They're supposed to go from exterior wall to exterior wall, or they can terminate at a smoke barrier, meaning they can run vertical for an extended portion of time and then come back horizontal, but again, protected from smoke. They're required to be constructed as smoke barriers so that smoke cannot go through the floors, and then any openings in the floors must be protected by either fire-rated joints or not just a normal damper, but a ceiling radiation damper, or any openings need to be enclosed in shaft construction. So they have a fire rating that is vertical. So if we go to our typical healthcare building and we add our containment for horizontal assemblies, you can see we're now starting to surround any potential fire and any smoke that would be developed by that fire by creating a barrier at the floor slabs. The next item is fire barriers. Now, fire barriers form most of your vertical fire-rated assemblies in your buildings. Like I said, they're typically intended to be used in shaft enclosures. They're intended for our exit stairs and exit passageways and enclosures, required for residential corridors, and typically required for hazardous rooms where a fire rating is required. So fire pump room, generator room, fire command center. And again, these fire barriers have to maintain continuity. They have to be continuous from floor to floor. Or, if you're looking in the other direction, from exterior wall to exterior wall, or they need to be connected to another fire barrier, and that other fire barrier will have to meet the same requirements, exterior wall to exterior wall, or to the next fire barrier. In addition to that, all these fire barriers are required to have opening protection. So you're required to have appropriately fire-rated doors, and those doors, unless meeting specific occupancy chapter requirements, are required to be self-closing. And then we have fire dampers in these fire barrier walls wherever they are a non-ducted system or where the wall is greater than 1 hour. In addition to that, you're required to have all your joints being fire-rated as well. So if we add to our example now the fire barrier component of our containment strategy, now we have a storage room, which is 1 hour fire-rated if it's more than 9 square meters, roughly. Or what we'll have is our exit stair enclosure or shaft enclosures, which in a 2-hour building would be 2-hour fire rated. So we've gone from our floor slabs, and now we've created the continuous 2-hour compartment for our floor. The next item, which is now getting into the next layer of protection, and is something that we don't see very often in the region, is the distinction between what is a fire barrier versus what is a smoke barrier. Smoke barriers have very specific functions in our buildings. And typically, they offer one level higher degree of protection where compared to a fire barrier because they're also intended to protect against smoke. And what you'll see is smoke barriers are required in buildings such as underground buildings, non-sprinklered educational occupancies, daycare buildings on upper floors of your building, healthcare, detention and correction, board and care, and firefighting lobbies. Now, what do these all have in common? Well, all of these occupancies typically have a defend-in-place strategy where you want people to wait on a fire floor because they can't evacuate vertically, they can only evacuate horizontally. So we want to protect them against that smoke. So for healthcare, where you have bedridden patients, they may be conscious or unconscious, or may not be able to leave their bed, they can't take the stairs. So they have to evacuate to the other side of the building, and they need to be separated from the potential fire and smoke by a smoke barrier. Again, smoke barriers need to be continuous, similar to the fire barriers, and their openings have additional requirements. So as I said, not all smoke barriers must be fire rated, even though most of them are fire rated. So openings are required to be protected by not just fire doors, but fire doors that are also designed to protect against the spread of smoke. Any duct penetrations through these and any air transfer openings not only need to be protected by a fire damper, but a combination fire smoke damper. So typically a fire damper will just have a fusible link, and when it gets to a certain temperature, it would close, but that would still let smoke through that opening until that smoke gets to the adequate temperature. Well, not for a smoke barrier. The smoke barrier also has to activate on smoke. So you'd have a detector, either an area-wide detector serving a zone, or a detector within the vicinity of that damper that, upon detecting smoke, it would actively close that combination fire smoke damper. In addition to that, all joints and other penetrations not only need to be fire rated, but they also need to be smoke tight. So if we take our horizontal floor slabs, our fire barriers, for a healthcare occupancy, we're required to separate our building into zones. So 2,100 square meters is the maximum zone size. So we'll have some form of barrier that runs perpendicular to our rooms. And to see this in plan view, it would be a barrier that basically separates two halves of a building, so that if there's a fire in one half, you move everyone to the other half until they can be evacuated via lifts when they're deemed safe, or they can wait until the fire is extinguished. And the final layer of complexity is for smoke partitions. Smoke partitions are a lesser degree than fire barriers and smoke barriers. They're only really intended to prevent the spread of smoke. So they're really just the first line of defense in our smoke strategy. And typically these are required for corridors to make sure that patients or students that are in other rooms but in the same compartment can at least get to the corridor to get to that smoke barrier before the smoke gets out of the room. So it's not really intended to prevent the fire from going from one area to the next. It's prevented to give a little bit more time for people to get out. And what these barriers do is these barriers offer us best of both worlds. It's a compromise on making sure that we have nicely designed corridor walls, we have visual cues through so they can be glass, they can have mail slots, they can have pass-through windows for healthcare. So they offer us the functionality in our building, but also give us that layer of defense for that first, once the fire initiates and we have smoke starting to spread, it contains it in that room until everybody in that area can get out of the building. There are also examples of hazardous rooms that are lesser of a hazard and include sprinklers. Instead of having a full fire-rated wall, you can have a nice glass door on it. And also building entrances from parking garages. We all go to our malls. We all see that there's requirements for retailers to guide people into the mall, and so you have nice glass doors, and you can see this in malls, Dubai and Abu Dhabi. And these glass doors would, under NFPA, require to meet the requirements for a smoke partition. Non-rated, but smoke tight. And again, these have requirements for continuity, except these ones can terminate at a smoke-tight ceiling, again, for corridors. If you wanted to run services above your corridor, you can just create the outline of your corridor going from the wall up to a smoke-tight ceiling and then back down to the other side. And then openings are lesser strenuous than what they'd be for, they don't need particularly a fire rating if the wall's not fire rated. So, but doors, for example, can't have louvers on them. All right. You require smoke dampers in certain areas. Sometimes you would not if it's a ducted system, for example. But if it's just an opening in a wall, then it would need to have a damper. And then smoke-tight joints and penetrations without necessarily the fire rating. So if we, in our healthcare occupancy or similar education occupancy, where we need to be able to have that first line of defense, we'll go and we'll add our smoke partitions. Non-rated, meet the requirements of the health authority, but also meet the needs for evacuating patients to the next compartment. So we pull everything together in an NFPA smoke control strategy. This is really the strategy as a whole. We have our fire partitions protecting our corridors, our fire barriers protecting our vertical exit routes and our hazardous rooms, horizontal assemblies protecting floors above and below. We have our sprinklers trying to suppress the fire, slow the growth, give civil defense more time to get to that fire. And if we're a high-rise building, then we require to also pressurize our stairs. But that's it. That's the whole smoke control strategy. And if done correctly, we've shown in the United States it works very well. And the biggest contributing factor to that is the sprinklers. So one thing that we've started showing on our plans to identify where we have a fire barrier, where we have a smoke barrier or smoke partition, is the use of one more layer of designation of walls. So for example, you'll have a 1-hour smoke barrier shown in purple on the right-hand side of the corridor because that's the routing of our smoke zone. We have a 2-hour barrier on the left side of our corridor because civil defense wanted us to increase the fire rating of our operating theaters, which were on the left-hand side of this plan. And then we have corridor designations, which then not only tells you what the wall rating is, but it also tells you how to protect all the openings, all the joints, and how to successfully implement a smoke containment or smoke control strategy. So again, if we look at the comparison of what we see are all the available systems versus what would be required under NFPA, you can see there are many more systems available, but that NFPA wouldn't necessarily require. And what we're looking at is, instead of focusing on all the other systems that could potentially be implemented, but are more difficult to implement, NFPA simplifies it into, let's make it passive, let's focus on the physical construction and make sure that component works before going to complicated, detailed smoke control systems that require numerous parties, a very well-coordinated design, installation, commissioning, and constant retesting on any building modification. The last item I put on the asterisk is also, obviously, interior finishes. If you go back to, for example, the MGM Grand Fire, that was a big interior finish and non-sprinkler protection issue, so that also plays a role as well. I just don't see as much of an issue with that in our construction. So I hope that sparked some ideas, and I look forward to debating the various strategies for smoke control or discussing them in further detail. Thank you.
Many thanks, Aaron. A lot of information there. Not easy to kind of sum that up, but I think there's a couple of things I just wanted to kind of subtle things perhaps that jumped out at me. And one of the things is that the codes are minimum requirements. You know, I think in a lot of cases we look at meeting the requirements of the codes rather than exceeding them. And I think that fire safety engineers, fire safety engineering companies can help in a great deal with not only meeting but exceeding and tailoring requirements. I also thought that in that particular context, it's very, very important to get the use employ a fire safety engineer when buildings change use, even when they change ownership, and that different operators will look at things in a different way. Because I think that that's when we start punching holes through roofs, we start punching holes through walls and ceilings, and that's when we start making the actual original fire safety strategy for the building weaker rather than stronger. As a facade specialist myself, I was particularly interested to see that the horizontal assemblies also actually include part of the facade. You'll notice from Aaron's presentation where he first introduced the horizontal red line, he also introduced 2 green lines at the facade, and that's a very important part of the facade design and the way that we stop fires from moving vertically. And I think that's something that's very close to my heart as a facade designer. But overall, one of the things that really struck me from Aaron's presentation is that so often we think about smoke control as active systems, notwithstanding the fact that you mentioned that sprinklers, have a great deal to do with it, but we think about extract fans, we think about extract ducts, we think about jet fans moving smoke, but so much of what smoke control, how we can achieve smoke control is actually provided by the passive systems. And in particular, I think that's kind of going full circle on this, it's actually kind of useful because some of these active systems are notorious for failing if they're not maintained properly. So as you say, it takes this degree of control and use and maintenance away and keeps these passive systems as the main fire barrier and the main smoke barrier. So thanks again, Aaron. Thank you.